Topic 3.4, integration by parts, question 3b, the integral of e to the power of x cos of 4x. So again, here when we're choosing our u and our dv, there's no ideal candidate because neither of them, neither exponential or a trigonometric function will differentiate down to 0 ever. So it doesn't actually matter here which one you pick for u and which one you pick for dv. However, I would say it's easier to differentiate cosine of 4x. So if I differentiate cosine of 4x, it differentiates to minus 4 times sine of 4x. So the cos goes to minus sine, and the differential of 4x is 4. And the integral is easy as well. The integral of cos of 4x is just going to be sine 4x over 4. So why would I choose to differentiate rather than integrate? Because if I integrate, I end up with a fraction, and it's just usually ends up with a bit more work. So I'm going to choose my u to be cos 4x, but it doesn't matter which one you pick. Okay, so dv is equal to e to the power of x. So in this case, du dx. So the derivative of cos, as I said, is minus sine, and the derivative of 4x is 4, so minus 4 sine 4x. And the integral of dv is e to the power of x, so that means v is equal to e to the power of x. And over here, du is equal to minus 4 sine 4x dx. So I got my important parts, my u, my du, my dv, and my v. So we'll do our integration by substitution. The integral of u dv is equal to uv minus the integral of v du. Alright, so the integral of u dv is what they've given me, e to the power of x, cosine of 4x. U times v now, so that's u times v, that's cos 4x by e to the power of x. So I'm going to say it's e to the power of x cos of 4x minus the integral of v du. So v du in this case is e to the power of x by minus 4 sine 4x dx. So I'll write that as minus 4 e to the power of x sine of 4x dx. Okay, so we got an unholy mess in there. Just to make things easier, I might just lash this minus 4 outside here to make it a little bit easier to look at. So the integral of e to the power of x cos of 4x is equal to e to the power of x cos of 4x plus 4 times the integral of e to the power of x sine 4x dx. Okay, so we have the same problem now again here. That's not easy to integrate, so we'll try and integrate it by parts. And once again, this time we're going to choose our u is equal to the sine because it's easier to differentiate it and integrate it, but again, it really doesn't matter. And dv is equal to e to the power of x. So du dx, so derivative of sine is cos, and the derivative of 4x is 4, so it'll be 4 cos 4x. The integral of dv is just e to the power of x, so that means v is e to the power of x. And then I've got my du equals 4 cos 4x dx. So I got my 4 important pieces, and I put them together using my integration by parts formula. So the integral of e to the power of x cosine of 4x equals e to the power of x cos of 4x plus 4 times, and now I have to do the integral of this. So u times v, sine 4x by e to the power of x, that's e to the power of x sine of 4x, minus the integral of v du, e to the power of x by du, which is 4 cos 4x. So 4 e to the power of x cos 4x. Okay, and what I might do is, seeing as that 4 is multiplying there, I might just pop him outside. Okay, alright, so we've got our brackets. So we've got our e to the power of x cos of 4x equals e to the power of x cosine of 4x. Now let's multiply our 4 in. 4 by this is 4 e to the power of x sine of 4x, and 4 by this is minus 16 times the integral of, and I might as well do my integral. Oh no, sorry, I'm not doing my integral. Minus 16 times e to the power of x cos of 4x. Okay, so things are not getting easier. Those integrals are not getting easier. But what I have here, the thing I'm looking to find is the integral of e to the power of x cos of 4x. That's what they're looking for me to solve. And it appears again on the other side as minus 16 times e to the power of x cos 4x. So seeing as I've got an equal sign, I'm just going to bring this minus 16 times my integral over to become a positive. So I've got e to the power of x cos 4x. And when the minus 16 times the integral comes over, it comes plus 16 times the integral of e to the power of x cos of 4x. And on the right side, that's equal to e to the power of x cos of 4x plus 4e to the power of x sine of 4x. Okay, so here I've got e to the power of x cos 4x, and here I've got 16 times the exact same thing, and they're adding. So altogether I have 17 times the integral of e to the power of x cos of 4x. That's e to the power of x cosine of 4x plus 4 times e to the power of x sine of 4x. So the thing that they're looking for me to find is just this part here. That's the integral they asked me to solve at the start. So to get that on its own equal to something, the 17 is multiplying it, the 17 will have to come over to divide. So e to the power of x cos of 4x equals e to the power of x cosine of 4x plus 4e to the power of x sine of 4x, all divided by 17. Don't forget your plus c at the end. But also remember that we can actually, if we wanted to have, instead of the whole thing over 17, you could have the individual pieces over 17. It makes absolutely no difference.